This video explains our IP data throughput testing solution for 5G devices. Part 2 demonstrates IP data throughput testing with 5G devices using the SmartStudio and our IP Performance MX800 1071A software. This demonstration measures downlink 5.12 gigabits per second throughput at the TCP layer in a UTRN new radio dual connectivity ENDC with NRFR1 downlink 2CC4x4 MIMO and LTE downlink for CC2x2 MIMO. Note that the appearance of the evaluation board type device used as the device under test DUT cannot be shown. Software includes the MX800 1071A to measure IP data throughput, and the LTE-NR platform software for SmartStudio MX800 1078A to run ENDC in one unit. This shows the RF connections between the simulator and the DUT. MT8000A Slot 1 outputs NRFR1 downlink 2CC4x4 MIMO and Slot 2 outputs LTE downlink for CC2x2 MIMO signals. In this demonstration, the LTE signal is not output to the cable shown as a dashed line. The StackSim ACC380 is a spatial combiner that applies phase shifts on each signal being input and combines them into outputs. All signals output from the MT8000A are combined and input to the DUT side, so signals can be transmitted and received even when information, such as frequency bands at individual antenna ports on the DUT side, is unknown. In addition, even if the CC number for CA or MIMO number is changed at the MT8000A side, the routing change like RF cable reconnection is not required. This allows automation of continuous IP data throughput testing under several different conditions. This is the system configuration of this demonstration. The external server is a Dell PowerEdge R240. The MT8000A has the enhanced RF module MT8000A033 in slot 1 and 2. Note that the appearance of the DUT cannot be shown. The StackSim ACC380 is underneath the DUT. This control PC runs the SmartStudio NR IP Performance MX800 1071A software. The throughput monitor screen shows the measured throughput. The throughput monitor is explained in more detail later. This is the control PC screen of the SmartStudio NR IP Performance MX800 1071A software. The number of cells and RF sharing are set at the simulation parameter setting window. The previously created simulation parameter file is loaded first. In this demonstration, 2 cells are selected for the NR base station and 4 cells are for the LTE base station. RF sharing is set as LTE1 and 2 a pair, LTE3 and 4 a pair, and each pair are in a sharing relationship for LTE downlink. The frequency, channel, bandwidth, modulation order, etc. are set at the cell parameter setting window. First, load the previously created cell parameter. Select band N78 and N78 and the corresponding downlink channels for NR Cell 1 and NR Cell 2, respectively. Select 100 MHz BW for the downlink bandwidth, 4 for the number of downlink antennas, and 256 come for the downlink modulation order. The per-slot downlink and uplink allocation are set at TDD configuration setup window to optimize throughput rates. Check settings of LTE cells 1 to 4 here. Select bands 1, 3, 7, and 7, respectively for each LTE cell 1 to 4, set the corresponding downlink channel, 20 MHz BW for the downlink bandwidth. Two for the number of downlink antennas, and 256 come for the downlink modulation order. Set RF sharing so the LTE 1 and 2 pair and LTE 3 and 4 pair are each in a sharing relationship. The blue circled symbol indicates that RF sharing with another LTE cell is in progress. Click the Start Simulation button to start simulation. The test scenario finishes loading and the DUT status is displayed here as power off. The DUT is activated, and the LTE side enters the call connection status via position registration. Next, select option 3XNR2CC's LTE 4CC's and click the Start Test Case button. The NR side enters the call connection status as well. The throughput monitor screen is displayed to check the throughput rate at the MAC layer. Open iPerf to check the throughput at the UDP layer. Then execute the server-side iPerf command, followed by the client-side iPerf command. Displaying the throughput monitor window again to show the throughput rate of 5.12 gigabits per second as NR plus LTE total at the UDP layer. Next, change the client-side iPerf command to check the throughput rate at the TCP layer. Execute the iPerf command. Displaying the throughput monitor window again to show the throughput rate of 5.12 gigabits per second as NR plus LTE total at the TCP layer. Stop iPerf. Stop the SmartStudio NR IP performance simulation. Even after the test, throughput rates can be reconfirmed at the throughput monitor window by switching to the required scale and time axis. This demonstration shows how easy it is to measure throughput rate using Anritsu's IP data throughput test solution for 5G devices.